Let's talk about elastic property of a stretched wire. Okay. Now here, if you are going to apply some force or some load on a wire, the wire is going to stretch, correct? And because of that stretching, there is some sort of elastic potential energy. Okay, now how does this develop potential energy? Let's look into it. It's very simple. Whenever you have a spring, okay, say you're going to apply some force, or let's say you're doing some work, and because of the work, the spring is going to extend. There is expansion in the string. Now, the work, whatever you're doing, that is being stored as potential energy in the spring. Okay, now spring, I just gave an example. It is true for a wire also. Okay, you have a wire, you stretch the wire. Okay, and then that means you're doing a work on stretching the wire. Whatever work you're doing, that work is being converted into potential energy. Understood? Now let's look into the mathematical part of. Now, what is work done? Force into displacement. Correct? Now here you're applying a force. Because of the force, there is displacement. Correct? Now let's look at what is force and what is displacement mathematically. You have a wire, correct? Say the length of the wire is L. It has an area of cross section, correct? Area of cross section, you can call it as A. Okay? Or pi r square, you can take it. Anything, any one of them. Then you're applying a force. Let the applied force be F. When you apply an external applied, when you're applying a force, it causes the change in length. Say the increase in the length is delta L. Alright. Now, if you apply a force, there is internal force also, correct? Now, Newton's third law of motion, external internal forces should be the same. So, even the internal force is going to be F, capital letter F. Correct? Now, before you apply the force, the internal force was 0. Correct? Once you apply the external force, now the internal force is capital letter F. So, what is the average internal force? 0 plus F by 2, which is F by 2. Isn't it? Now, what is work done formula? Force into displacement. Correct? Now, when you say force, the average force. So, you have work done W is equal to F by 2 into delta L, the change in the length. Isn't it? F by 2 into delta L, or this work done is stored as potential energy. Isn't it? U is equal to half into F into delta L. Now multiply and divide by A and L. That means you have half F by A into delta L by L into A into L. This becomes half into F by A is stress, delta L by L is strain, correct? Half into stress into strain into volume. Isn't it? Now the same formula can be written in another way, which is half into Young's modulus into strain square into the volume. Alright, in terms of Young's modulus or in terms of stress and strain. This is the formula for the potential energy stored in a stretched wire. Understood? So remember, this is potential energy. So the SI unit becomes joule. Okay, let's recap the formula one more time. You have half into stress into strain into volume, or half into Young's modulus into strain square into the volume. Alright, these two are the formula for potential energy in a stretched wire.